Hi. Now in this tutorial what I want to do is introduce you to terms in expressions and equations. It's so important when simplifying expressions and solving equations that we understand what we mean by a term. So to illustrate this, it's best done through examples. And so what we'll do is we'll start off with an expression, simple expression, 3x plus 5. Now, by a term is something that is separated generally by a plus, a minus, or an equal sign. And in this example here, we've just got this plus here. It separates what we call this term from this term here. We've got two terms. We've got an x term, the 3x, and we've got this number here, often referred to as a constant. Now let's have a look at another expression. Let's say we take 3 and then we put a plus in. We've got one term immediately, okay? And then we're going to add to this 4x. And if I put, say, a minus, I've got a separator now. I've got one term here, one term here. Let's just ring those, okay? So I've got my separator, and then suppose I put minus 2 and then minus x. The minus here separates our terms, so we've got another two terms. 4 terms then in total, two constants, the 3 and the 2, and two x terms, the 4x and the x. And if we had to simplify this, we've got 3 minus the 2, which is 1, and we've got 4x minus the x, which is 3x. So we're left with 1 plus 3x. I'm not going to put that in because we're not really dealing with that here in this video. Now in my next example, what I want to do is introduce you to brackets. If I write x plus 1, I've got a separator here, so I've got two terms, the x and the 1. But if I put brackets around this, it groups up these two terms into one term. And even if I multiply this, say, by 3, it still doesn't alter the fact that it is one term. But as soon as I put in, say, plus here, I create a separator. And so what we've got now is just the one term here, and I'm going to add to this, say, 2x. And so I've got another term here. Two terms then. Let's take this again and we'll develop it further. Let's suppose we have then 3 bracket x plus 1 plus our 2x. So we've seen from above that this is two terms. If I was to put this all in brackets, it becomes one term. If I introduce a division though, it's just like putting all of this in one bracket. So the division kind of wraps it all up. And if I just put, say, 4 here, I've got one term. So let's just put that like that, okay, signifying the one term. And then to this, I'm going to say subtract, there's my separator, say 3x. So I've got an expression here with two terms. Let's introduce another idea. In this next example, we'll take x plus 2. We've seen from above, here's our separator, I've got two terms. Now if I take, say, the square root of the x and then add the 2, I've still got two terms. But if I extend this and square root all of x plus 2, it now reduces down to one term. If I put a separator in here, the minus, and let's say I have 5, I've got another term. If I decide to divide this by, say, x, then the division, just like this, still keeps this as one term. Even if I put, say, x plus 2 here. I've got 2 terms in the denominator, but the division really wraps the whole lot up as 1 term. So I've got 1 term here, and then I've got another term here. Okay, well, that's enough for expressions. Let's have a look at equations and carry on extending our ideas. Suppose we take an equation now, say 3x plus 5, or minus 4, say, okay? Similar kind of thing to this. We've got 2 terms. But by introducing an equals sign, we create a separator. And if I had, say, x minus 2, what I've got now is 1 term here. Let's just ring that. I've got another term here. We've got a separator, so we've got another term here, the x, and another term here, the 2. If I put this, however, in brackets, I'm now down to 3 terms. 1, 2, and all of that is 3. And it doesn't matter if I multiply this by something, it's still 3 terms. So we'll just ring that like that, okay? A simple equation with 3 terms. X term, constant, I don't know what that is, okay? Just leave it. If we were to expand it, we would get 5x minus 10. We'd have 2 terms then. We'd have an x term and we'd have a constant. Okay, next example. So if we've got, say, 2 multiplied by x minus 3, we've got 1 term. We've seen that if I divide this, it's still 1 term. If I divide it, say, by 5, it's still 1 term. If I put another term in the denominator here, the denominator consists of 2 terms, but still overall it's 1 term. And then if I put equals 2x, I've got 1 term, because the equals is separating this from this term. And then I put minus, say, 1, so I've got 2 terms here on the right hand side. And if I divide this by 4, it's still 1 term there. So in all, this is a total of 3 terms. So I hope you're getting the kind of idea at the moment. Let's go back to square roots. A square root wraps up something as 1 term. So if I just put a square root around something, it's 1 term. It doesn't matter what I've got in here, x minus 3, all divided by, say, x plus 2. It's still 1 term. If I was to analyse this 1 term, break it down, we've got a numerator here which consists of 2 terms. And the denominator consists of 2 terms. But overall, it's 1 term. And if I just say that this equals, say, 2 bracket x minus 1, let's say plus 3, then I have got a term here and I've got a term here, a total of 3 terms. Okay, so let's just ring those in the usual way. Last one, alright. Let's suppose we have 5x minus 3, 2 terms, put it in brackets, 1 term. And if I still multiply this by something else, it's going to be 1 term. And so let's multiply it by something else in brackets. Within the brackets here, I've got 2 terms, x plus 4, but overall, it's still 1 term. And let's say equals, that's a separator, and it equals, say, 0. 0 is also another term. So we've got 1 term here and 1 term here. Okay, well, I hope it's given you an idea then, both over expressions and equations. If you're looking at this on my website, you'll see that there is a summary video below this, which I'd strongly encourage you to try, just to recap, okay, the work that we've been talking about so far. Okay.